Now that you have learned all about subtype supertype structures, we turn to the constraints that we can express on subtype supertype structures and the various ways they can be represented in a data model diagram. This includes the exclusion or non-overlapping constraint and the mandatory or total inclusion constraint. We also discuss how membership in a subtype can be well defined based upon attributes of its supertype. We will end with an example of using subtype supertype structures in a subscription database for a periodical journal. In fact, you have already seen some expression of the graphical representation in the last lecture. Most modeling schemes which include subtype supertype structures do not allow you to represent the full range of constraints, which we will be showing you in this video.
All right, so we've hinted at the notion of constraints. Without constraints, I said we want to assume the most general case, and the most general case is overlapping subtypes. Otherwise, you declare a constraint, exclusion constraint. And the second is non-exhaustive, or let's say it's partial. It says that every supertype does not have to play in one of its subtypes. That's what we mean by exhaustive. The supertype instance need not be in any supertype. Otherwise, we can declare a mandatory constraint on the supertype and say you must play at least one of the subtype roles. That is, all of your subtype populations together exhaust the population of the supertype. So that would be another kind of constraint. And you can see that it really is very much like the exclusion constraint on a many-to-one relationship or the mandatory constraint on an object. So we declare constraints in the more restrictive cases. Some systems allow only disjoint and total declarations. And so you have to compensate for that in your model as best you can. Okay, it's possible to model overlapping even if the system only allows disjoint, and we did that already. Some systems make disjoint and or total as the defaults, and you declare otherwise if they can be overlapping. Diagramming constraints. There are three possible constraints that we can define. The exclusive constraint, we've already seen an example of that, where the two subtypes, or there could be multiple, you could have 3 or 4 subtypes all connected and say you can play in at most one of those. The exhaustive constraint is a constraint on the supertype. That says that you must, if that constraint is applied, it says you must belong to at least one of your subtypes. And then there's an exhaustive on the subtype, which means if you're in both your supertypes, you must play in both of them. You must be in both of them. So in this example, I'm showing supertype, and then it's man, woman, and child. All right, well, you can see I've got an exclusion between M and W and C. Okay, that says you can't be in 3 of those. You can only be in at most one of them. And then I've got this mandatory constraint across those 3, and it says you must be in at least one of them. Notice the at least and the at most. The dot says you must be in at least one of them, and the exclusion means you must be in at most one of them. Very parallel to what we had before. And then the third one is the dot that's on the C here. It says if you are in both S and S2, both of the subtypes, then you must be in C. Otherwise, you don't have to be in C. So what would we call the population C if we applied this constraint relative to the 2 supertypes? What would you say about C? What is C with respect to the 2 supertypes? Is it the union? The two supertypes are two populations. It would be the intersection. It would be the full intersection of the two supertypes. That's what you're saying when you put the mandatory constraint on the subtype. So here's another example. I've got the supertype, S, and then I've got subtypes, oviparous, mammal, bird, and fish. Now, I'm not a biologist, but I'm told that it can't be both oviparous and a mammal. Oviparous means born outside of the body, isn't that right? Like an egg. B, bird, okay, is a subtype of oviparous. So you see how we've shown that? You can have these kinds of interrelationships if you want to. So you can't be both a mammal and a fish, so we've got the exclusion on that. Just an example of how you can mix these things up. Notice that it would be very difficult to express these constraints if you're using the nested notation for subtype supertypes, which is why we don't typically do that anymore. Some tools do. Okay, well, just briefly, there are four. You can have the unconstrained and the constrained case, and then in both the dependency and in the exclusivity. So in ORM, we're going to use the X to mean exclusive, and the default will be overlapping is allowed. And for the total, the default will be partial. In other words, you don't have to play in any of your subtypes. And if you do, we'll declare that as a mandatory constraint on the supertype. Alternative notations, in IE, they put the X for exclusive inside that little icon, or not if it can be overlapping. In EER, you can see what they've done. One alternative was put a D if it's disjoint and put an O if it can be overlapping. In another case, if it can be overlapping, they put it a solid diamond, or triangle rather, or an open triangle. And you know, some of these are visually intuitive and appealing, and some of them aren't. But I'm just telling you what the choices are in these various modeling schemes that be used. Okay. Notice in IDEF1X, you can only define disjoint subtypes. And so you have to go through that kind of transformation that we talked about. And then for total and partial, if it's partial, then you have the little circle separated a little bit here from the subtypes. In UML, or object definition language, in UML, there is no symbolism that they use. You have to just express it in words. Okay? And also in ORM, we permit you to combine the exclusive and the mandatory because that's not an uncommon situation. You can combine them into a single graphical notation. No modeling scheme or schemes recognizes the totality on the subtype. Okay. So that's why I didn't list it in the table. When we have a subtype, the question arises, what's the rule for a member of the supertype belonging in the subtype? There will be some criteria that can be used. It's going to be some characteristic or attribute or relationship that's on the supertype, which will be the basis for membership in the subtypes. We call this the distinguishing attribute. In general, it could be any combination of attributes associated with the patient, or in this case, the supertype. Okay? So, in this example, if I was having subtypes of males and females, and I had then the sex attribute attached to the patient, and it has the values M and F, with that many to one, and it's a required, what can you tell me might be the rule? Well, simply, if the patient is of sex male, it goes in the male subtype, and if patient is of sex female, it goes into the female subtype. Now, how does this translate to the constraints that we would have on the subtype supertypes? All right? Well, it's like this. The dot there, the mandatory dot that says every patient must have a recorded sex in the database, that translates into the totality constraint that says all patients must participate in at least one of the subtypes. You understand that? If I didn't have the dot, it said that some patients could exist without being associated with the sex field and therefore not have to appear in any of the subtypes. So that would be like a partial covering. All right, the other one, if we look at the exclusivity, how many different values, instances of the sex field could a patient belong to? Well, it's only one. It's exclusive. And so what that says is that those subtypes are exclusive. You can't be in both of them. Okay? So what we're showing in the patient-to-sex relationship is that you must belong to at most one sex. All right? So that says something about membership in the subtypes. If it's optional, then you don't have to belong to either one of the subtypes. In general, if we have a defined rule for membership in a subtype, this is called an intentional set. The subtype is considered as an intentional set. We have a rule for including the supertype instance in the subtype. We define it in terms of the values of supertype attributes, quote attributes. In general, it could be a Boolean expression across any number of the attributes. You could consider it as a constraint rule, if you like, on subset membership. There are many possible subgroupings or specializations of any type based upon any of the values of its attributes. So we look for those that matter. Notice, any attribute of an employee, if I have an employee supertype, any attribute of an employee could be the basis for setting up subtypes. It's not always possible to define the rules of membership in a subtype. And for that, we call that situation, the subtype would be an extensional set. Okay? An extensional set is simply one that says, you belong to the subtype because I say so. System doesn't know when you should or shouldn't belong to a subtype. And so some user or somebody outside of the system puts them in a subtype. That's what we mean by extensional. By mere existence in there, I've told you to go there, then you belong in that subtype. Okay? This is the database version of Jean-Paul Sartre's extensionalism. The inclusion is determined by the existence of the set. Membership is manual. That's another way to think about it. Membership is manual. The system can't automate or validate membership. Some systems require that there be a definition. Interestingly enough, in the tool, the Visio tool that's in Visual Studio, they require that there be a subtype definition, but all it does is it looks and sees if there's something there, that there's some text there, but it doesn't do any interpretation of that. We can always come up with an artificial distinguishing attribute. Okay? We can say the attribute could be which subtypes are you in, and then have that relationship be the basis for membership. There could be fixed subtypes where we belong. Once you belong to a subtype, you will always be in that subtype forever. That's the same as the fixed constraint that we talked about in the ER modeling. Or we could have role or phase state phase and state subtypes. An object plays different roles, and those roles can change. It moves through various stages or states. Okay, so we have subtype definition, and there's extensional and intentional definitions, if you like, of membership in the subtypes. An example, this is one right here at home, the MIS Quarterly, which the university here publishes. This was an early view of the way the database was set up, the subscription database. We have colleagues, and that's what they called individual subscribers, and then we had libraries, and those were organizational subscribers. And you can see associated with each one of those, we've got claims, a line item, and a payment. And it's not important how those are defined, but you'll notice that colleague relates to claims, line items, and payments, and so does library, and in fact, so does agency. An agency, it was an agency that serves as an intermediary between libraries and publisher. Okay, so that libraries would go and say to the agency, get me all of these subscriptions, and then they would go and apply for the subscriptions for the library. So the library wasn't busy doing it one at a time. Okay, what do you observe? Okay, we're always, you know, when we do data modeling, we're always looking for commonalities, aren't we? That's what generalization is all about. And subtype, supertype is looking at generalities, generalizations. So what do you observe here? You're looking for commonalities. What can you see here? You're an experienced data modeler now. I want you to tell me, the users have shown you this as a proposal. What kind of questions might you ask? Do you like the way this is? Might there be a way to simplify it? I have a bunch of puzzled faces in front of me. I almost told you what it was. Look at all three of them, agency, library, and colleague, all connect to claims, line items, and payments. In fact, what's the difference between a colleague and a library? Only the nature of the entity, because they have the same kinds of relationships with the other things in the model. In fact, notice this is a subscription database, and is there an object here called a subscription? There is not. That ought to be a flag that something's wrong. Let's introduce the notion of a subscription. And now, the subscription, the people that relate to it would be the subscriber, the recipient. The subscriber isn't necessarily the recipient. Okay, one person could be the subscriber, and then they have it sent to somebody else. The payer could be somebody different again, and an agency may be involved. So a subscription could go through an agency. And this raises all kinds of questions. For example, some colleague could buy a subscription for a colleague of theirs. The university might pay for a subscription, but it comes to me and it's in my name. Interesting question there is, who does the renewal notice get sent to? The person who's the recipient, or the person who's the payer, or the person who's listed as the subscriber? These are the kinds of questions that have to be asked of the user environment. Who owns the subscription? Okay? So anyway, are we done? Now, there's no subtype, supertypes in here. You'll notice subscription is one kind of thing, and those other subscriber, recipient, payer, agencies is another type of thing. But what do you notice might be common across them? What would be common across subscriber, recipient, payer, and agency? Those are all roles of what? They're roles. So generalize. People? Organizations? I don't know quite how to get at this, but I'll click the next on the slide. What's likely to be common across these parties? These four parties. What's likely to be common? What would some of the attributes of subscriber be? Name, address, email. What would be for the recipient? Certainly address, name. What about payer? Have we uncovered some commonalities? Yeah. Okay. Call it a contact or something like that. Now, they play different roles, so it might be meaningful to first classify them as an individual or an organization, because beyond that, we really don't care from the subscription point of view. The roles, they could be playing one or two or three of those roles. I don't think it would ever be four, okay, with the agency there. But then you've got person name, position title, organization name. If it's a person directly, then it would be the organization that they're affiliated with. If it's an agency, for example, then the person would be the representative there for contact. Address, phone, email. Okay? This is a good example of where a subtype, supertype is useful. Okay? But notice how we got there. We got there by identifying some of the people or roles that are in the environment and seeing some commonalities across them, and that's what suggests that we have a supertype.
Now that you have a basic understanding of subtypes and supertypes and the constraints that can be expressed on them, subsequent lecture videos will talk about more advanced topics, particularly mapping subtypes and supertypes into relational tables. Just as an alert, those modeling schemes which include a representation of subtype, supertype relationships, almost all are limited in their expression of constraints. What you have heard here is the full range of subtype, supertype constraints and how they can be represented diagrammatically.